All right, what I want to do with you is show you the similarities between what we did on Friday and what we are going to do today. So this is exponentials and then logarithms. Because these are similar, very similar in nature, sometimes it's easy to get them confused. And so I want to try and help you keep them straight in your mind of which is which. All right, number one. First thing we learned about exponentials on Friday is that where their asymptote goes. Can you guys tell me from Friday, where does the asymptote go for an exponential? I hope you learned this. Okay, where does an asymptote go for an exponential graph? Which axis is that? The x-axis, okay. That is important. The exponentials have their asymptote on the x-axis. The way I remember it is just the sound of the word. Exponential starts with what sounds like x, and so it's on the x-axis. So try and use that to help you keep track of that, because a logarithm also has an asymptote, and its asymptote is on the y-axis. So you can imagine how disastrous it would be if you got them mixed up in your mind and you did everything backwards on a quiz. And every exponential you drew like a logarithm, and every logarithm you drew like an exponential. You've got to keep the asymptote straight. And if you know what asymptote goes on what axis, then everything else should hopefully come from there. Okay, number two. You want to hug the asymptote until you cross the y-axis. And when you cross the y-axis, you cross it at 1. All right, you hug the asymptote until you cross the y-axis at 1. Well, the logarithm is completely opposite. Sorry, that logarithm should have been labeled number 1, same as the other one. All right, number 2. So for logarithms, same thing. You hug the asymptote until you cross, now what axis do you think? The x-axis at 1. Okay, so you hug the asymptote until you cross the y-axis, the x-axis at 1. They are exactly the opposite of each other in every way. They're so similar, but you don't want to mix them up. Okay, which is which? It really all depends on your asymptote being right in the first direction. Okay, 3. In an exponential, which is the ones we just did, you draw your asymptote, you hug your asymptote, you cross the y-axis at 1, and then you curve steeply, and you do it towards that number b that we talked about. Okay, curve steeply towards b. In a log, you're also going to curve, but the opposite of curving steeply is curving in a flat direction. Okay, so we're going to curve, I guess we call it flatly. I don't really know a better way to do it. And we curve flatly towards B. All right, so what I'm going to do right now is draw the differences between these, and then we'll practice logarithms. Okay, so hopefully you've got all of that. I'm going to scroll up here. And I want to show you the differences between exponentials and logs. All right, it all is crucially dependent on where you put your asymptote. So exponential, X, it starts with the sound of the letter, and that's the x-axis is where you put your asymptote. So make sure you color or shade in the right asymptote. That's how, Michael, when I looked at your homework and I saw all your asymptotes going the wrong way, I knew you had done the wrong lesson. Okay, so that's how I could tell. Okay, exponentials should all be across the x-axis. Logs should all be down the y-axis. So on your open note quiz, it should be easy to keep them straight, but on your closed note quiz on Friday, you want to make sure you have those in your head. All right, then we hug our asymptote until we cross the x-axis at 1. Excuse me, the y-axis at 1. Okay, hug that asymptote, and after that, you curve steeply toward wherever B is. So we're going to curve steeply towards B. And that is the value of B. A logarithm also hugs the asymptote, but it comes up from the bottom, and it hugs the asymptote until it crosses the x-axis at 1. And this is where my vocabulary, I don't have a good word for it, but it's going to curve in a flat direction. It's going to look like it's going to flatten out, and it's going to aim toward the point B, but it's going to be going in a more of a flat direction. It's still going up. It's not perfectly flat, so I don't want to say flat exactly, but it's flatly. It's getting flatter. It's flattening out. It never gets completely flat, though. Okay, it never gets to be completely flat. It just is flattening as it's heading out to the right. Okay, those are the two different graphs. So what we're going to do now is just practice the log graphs 4 or 5 times until we leave for today, so we can practice. All right, so those are the beginning. The last thing I need to show you is go back down to underneath your notes here when you were taking about logs. There is a 4th thing for logs that didn't exist for exponentials, and it's the domain. Logs are the only other thing that have a domain that's not all real numbers. So now you already know 2 things that don't have all real numbers. The 2 things that don't are things with denominators and things with even square roots. Logarithms are the 3rd one. They do not have a domain of all real numbers. Their domain is whatever is in the parentheses. Okay, you take whatever's in the parentheses and you make it greater than 0. Domains are not allowed to be negative. Domains are not allowed to be even equal to 0. So you take whatever is in the parentheses. I just wrote parenth right there, or I tried to at least. That was supposed to say parentheses. I could try and make that a little better. You take whatever's in the parentheses of your log and you make it greater than 0, and then that's the set domain for that one. Okay, now let's graph. Okay, our first one I want to do with you, I'd like to graph log base 4 of x. Okay, this is just a basic one. So first thing you should always do is get that asymptote drawn. Okay, you got to get the asymptote in the right place so that you don't mess up anything else. If you get the asymptote in the right place, then you know, okay, I can't cross that asymptote. That's my guideline. So then a logarithm will hug that asymptote, and it'll come right up along near it and head towards number 1. And then it's going to curve off to the right, and this time it's going to go through the number 4 because the base was 4. So we'll head curving off through there as 4, and then you have your graph. So they're easy to draw. You have 2 guide points. You've got your asymptote as your guideline, and then you've got 2 target points that you're aiming towards, and then you draw it. So the graphs are not hard. Then you want to say what your domain is. Your domain takes what's in the parentheses, which happens to just be x right now, and sets it greater than 0. And that's all you got to do for domain. Take whatever is in the parentheses, set it equal to 0. The range for every log will be negative infinity to positive infinity. The lowest part of the log is clearly negative infinity. It's shooting straight down here. And now the highest part of the log, sometimes people have a hard time imagining that this log will actually get to infinity. And it will. It just does it really, really slow because it's not very steep at all. But eventually, with an eternal amount of time, it will get to infinity. So we say that its range is negative infinity to positive infinity. Okay, let's try another one. This time I'd like to do the log base 3 of x plus 2. So first things first, draw your asymptote so that you make sure that you're headed in the right direction. We hug that asymptote, don't touch it, hug it, curve towards the number 1, and what's my next target point? 3, because of the base. So I curve off to the right, and I head toward the target point of 3. Then I'm going to move this whole thing. So grab your asymptote, grab your dots, grab everything and move it 2 in what direction? 2 to the left. All right, I'm going to move this whole thing 2 to the left. So my asymptote moves 2 to the left. All my dots move 2 to the left. And so the new graph is now coming right up along there, curving and curving. Okay, so there's the position of your graph moved 2 to the left. Now that affects your domain, because your domain, you got to take what's in the parentheses, and what's in the parentheses is x plus 2, and you have to set it greater than 0, which requires you to do a little math on both sides, which is subtracting 2, and so the domain is x is greater than negative 2. The range remains unchanged for every log. The range will always have negative infinity to positive infinity as its values. Okay, any questions so far? All right, let's try a couple more. All right, the next log I want to do with you is an ln. And I'd like to do ln negative e plus 3. Okay, don't freak out because it's an ln. An ln is still a log, and you're still going to draw it the same way. You still get your asymptote on there as your guideline. Then you're going to hug that asymptote, and always hug going towards the number 1. And then I'm going to curve towards what number? 2.7. Okay, so 2.7 is right here. Okay, a little bit more than halfway between 2 and 3. And so I'm going to bend and head through that number. Might help if you labeled it 2.7, or you could label it E or something like that. Then we want to do a reflection. This negative is on the inside, and so I'm going to reflect the whole thing. Quadrants 1 and 2 will completely reflect over the y-axis to quadrants 3 and 4. And so the reflection will be completely backwards. But we're still going through negative 2.7. So the reflection is completely the opposite way. So now I'm going through negative 1 and negative 2.7. And the final thing is to shift this whole thing up 3. Whoa. So then I'm going to just drag all my dots and move them up 3 units from where they're at. The asymptote will move up 3 as well, which you won't be able to tell it's moving up 3. But all the other dots will move up perfectly 3. And so we'll come and hug the asymptote and then aim for those dots. And so that's the final position, is the red one. So then I want to think about the domain for that. Make sure you take what's in the parentheses, not what's outside of it. So I don't have to worry about the plus 3, it's not in parentheses, but I do have to worry about the negative x. And I set that greater than 0. The math I have to do on that is divide by negative 1. And what happens to an inequality when you divide by negative? Switch the sign. And so the domain is x less than 0. And the range remains unchanged. The range will always be negative infinity to positive infinity.
You call all real numbers the same thing?
All real numbers, same thing, sure. Yep. Okay, one more and I think we're done. All right, our last one would be y equals negative log base 10 of x plus 2, minus 2, I meant to write. Okay, log base 10, x minus 2. All right, so a log is a log is a log. It doesn't matter if the base, we still draw the asymptote. We still come along the asymptote and head towards the number 1. And then we bend and turn. And this one, when we turn, what number are we heading towards? 10. All right, now that 10 isn't always going to be there. Sometimes it'll just be missing completely. If it's missing completely, that is still the number 10. That's called a common log, and they don't, now 10 might take you a little bit off your 8, 9, 10. It might take us a little bit off the graph. So that's going to look real flat, like it's heading towards that number. So that's a base 10. Then you grab this whole thing, and 2 to the right is going to bump the whole thing over 2 to the right. So the asymptote will now be moved over 2 to the right, and the graph will be moved over 2 to the right as well. So everything is moved over 2 to the right. And including the asymptote. So the new asymptote is now 2 to the right. That will affect our domain. So I'm going to erase my original, get it off there. My domain, remember, take what's in the parentheses. So what's in the parentheses is x minus 2. Set it greater than 0. Add 2 to both sides. So x greater than 2 is the domain. And then the range, all real numbers, negative infinity to positive infinity. Oh, I haven't done that. I haven't done my reflection. Thank you. Forgot about that. All right, reflection just flips it. There we go. Okay, reflection upside down. Okay, beautiful.